Alright. A sequence is a set of numbers that are listed in order and that follow a particular pattern. One type of sequence that we can talk about is an arithmetic sequence. An arithmetic sequence is a sequence that has a constant difference. Consecutive terms just means terms that come one right after this sequence. So like if we had the sequence 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1 and 2 would be consecutive terms, 2 and 3, 3 and 4, 5 and 6, just terms that are right next to each other. Alright, so for one example that we're going to do, we're going to suppose Bernardo earns tickets from the local arcade. He starts out with 11 tickets and earns 4 more tickets for each game he plays. Bernardo can create an arithmetic is used to indicate a special case of a variable. So the term A1 indicates the first term of a sequence. And so on. So A3 would be the third term, A4, it's just whatever that little small number is, that's the term of it. So A1 is read A sub 1, so if you hear somebody say A sub 1, then you automatically think a letter and then a small little number in the bottom right corner. So back to Bernardo. Okay, so he has 11 tickets, and then he goes and he plays one game, and after every single game he earns 4 tickets. So he played a game, he got 4 more tickets. Now he has a total of 15 tickets. Okay, well, he goes and he plays another game. Well, then he decides, okay, well, I'm going to go play my 3rd game. And he finishes that and he earns 4 more tickets. Well, now he has 23 tickets. And then he says, okay, well, you know what, I want to go. He earns 4 more tickets. Now he has 27. And then, you know what, he's just like, let's go play another game. He finishes that. He earns 4 more tickets. Well, now he has 31. And so on. So if you have a list of numbers and 3 dots after it, just remember that just means it continues. So it would keep going. This is, if you notice, you get each term after adding 4 to the previous term. So you can actually use recursive notation to generalize an arithmetic sequence like Bernardo's. So all you do with this is you have to first state your first term. What is your first term equal to? Then you say you can find any term. N is going to be any number. You can find any term in the sequence. by taking the previous term and adding something. So kind of using that in our thing, term is 11. Okay, and then you can find any term by taking the previous term and if you notice, we took the previous term to find the second term. We had to take the previous term 11 and add 4 to it. If you want to try that out, we can find the second term. So you can say a2 is equal to, where you see an n, put a 2, a to the 2 minus 1 plus 4. Well, then that would be a to the 2 minus 1 is a1 plus 4. Well, a1 is 11, so that's 11 plus 4, which is 15. And it would work for each one from there on. Addend of 4 is used to generate the next term in the arithmetic sequence. In general, the addend in an arithmetic sequence is called a common difference, since it is also the difference between consecutive terms, which is what we're going to be putting right here. It's the addend. And that would be because another way to find 4 would be take the consecutive terms 11 and 15, and 2 15 gives you 4. So we know that to go from 11 to 15 you had to add 4. Alright. Now a geometric sequence. It is a sequence that has a constant ratio between consecutive terms. So whereas and division. So, for example, Kayla earns 2 cents the first week for her allowance, but each week she earns twice as much as she did the week before. She can create a geometric sequence allowance. Okay, so the first week she's getting 2 cents. Well, then week number 1 ends, and then they double that. Well, now she's earning 4 cents. And so now she's earning 8 cents. And the third week is over, and they double it again. So now she's earning 16 cents. And then the fourth week is over, and they double it again. So now she's earning 32 cents. The fifth week is over. And then the sixth week ends, and they double it again. Well, now she's earning $1.28. And then the seventh week ends, and they double it again. Well, now she's earning $2.56. And then the eighth week ends, and they double it again. And now she's earning $5.12. And on and on and on. So we started with 2 cents, but then in a couple of weeks we're already at $10. And so by the end of the year, if this continues, she would be earning quite a bit of money for an allowance. That is. So if you notice, the multiplier of 2 is used to generate the next term in the geometric sequence. So to find the next term, in general, the multiplier in a geometric sequence is called a common ratio, since it is also So you can also actually represent Kayla's sequence by a recursive rule. So remember, you state the first one. So you say the first term was $0 was 2 cents. And then to find any, so it would be 2 times the previous term. Use how you get the next one. Alright. So then, in conclusion, an arithmetic sequence has a constant addend or common difference. It is an additive relationship between terms. So if you're doing these and you're trying to figure out if it's an arithmetic sequence or if it's a geometric sequence, one thing to look at is, does it have a constant addend? So if you take the second term, are you adding the same thing to each term to get the next one? If it's a yes, then you're an arithmetic sequence. If it's a no, then you're a geometric sequence, because it has a constant relationship, constant multiplier, or common ratio. It is a multiplicative relationship. Between terms of a sequence. So let's say instead of them not having the same number between each other, you do notice that they have the same number. So if you take the first term like this one and you can multiply it by 2,